This is what I call Chapter 7, Organic Chemistry. This is going to be what our focus is. This is going to be all brand new material for everybody in class. So we are done with our review. And so what this lecture is going to focus on is what we call the basic functional groups of organic chemistry. So on the top of your notes here, write down carbon. Is going to be our big focus with these molecules. So carbon, hydrogen, oxygen, nitrogen, and the halogens, those are going to be the major elements or the major players of what we're going to be talking about in organic chemistry. So I always like to start with the first grouping, which is the alkanes, alkenes, and alkynes. These are what we call the hydrocarbons. Okay, and they are exactly what they sound like. They are hydrogen and carbon. So we have alkane, alkene, and alkyne. So alkane is anything with a single bonds in it. Alkene is a double bond, at least one double bond in the structure. And finally, alkyne is a triple bond. Okay, so it doesn't really matter how many carbons you have linked up. And we were starting to draw a couple of these. Please note that if all of the carbons are bonded together singly, that's called an alkane, and their ANE is going to come into play. If I have a double bond somewhere in the structure, that's considered an alkene, ENE. What happens is you have less hydrogens in those molecules because you have the double bond somewhere in that structure. And then a triple bond. Again, a triple bond could be anywhere. But please note that it limits a lot how many hydrogens you could have. So if you have single bonds, it's alkane, alkene, and then YNE is going to be an ending we're going to see when we start to name these molecules. Those are what we call the basic hydrocarbons. Then we start to get into where we introduce oxygen to the hydrogen carbon mix. So the first, what we call functional group, how we could separate these carbon molecules, is what we call an alcohol. And we're going to be using its symbol R, and R is going to mean number of carbons. So this could be, 2 carbons, 6 carbons, it doesn't matter. But what makes something an alcohol is it has an oxygen with its 2 lone pairs, which you're going to see those lone pairs kind of disappear, and it has a hydrogen, okay? So typically you see it written as ROH, okay? So that is what we call an alcohol. Now the alcohol group can be anywhere in a carbon molecule. It does not matter where it is located. We will talk about how we name them depending upon where the OH is located. But really we are focused on it has an OH. If it has an OH, it's considered an alcohol. So it's kind of the grouping that we put them in. Ethers are going to be, again, R group, so as many carbons as you want. It has an oxygen in between 2 carbons, okay? So again, I'm going to stop drawing some of the lone pairs on oxygen, but I do that to kind of give you an understanding. So I could have 1 carbon on one side and 2 carbons on the other, it doesn't matter. But that oxygen is not going to have any hydrogens attached. So you're just going to have 2 carbons on either side at least. And again, you could have 6 more carbons, 10 more carbons on either side, does not matter, okay? Aldehydes, again, an R group, you have a C, then this is where you start to see what we call a double bond oxygen. So carbon is double bonded to an oxygen. Here are the 2 lone pairs. And then this carbon has a hydrogen, okay? So because of this setup, it's what we call an end group. So it's always going to be on the end of the molecule because it can only make 1 more bond. So you can't put this in the middle, okay? So, and it doesn't have to be on the left or the right. It could be anywhere in, it could be left or right in the molecule. It just can't be in the middle, okay? And it could have as many carbons attached as possible. So this is the part of the molecule that makes it an aldehyde, Then we have another double bond. So these are now starting in the C double bond groups. This is a ketone, C double bond O. And then I have at least 1 carbon on either side, okay? So ketones look different because that C double bond O can be somewhere in that molecule, okay? So again, I could draw as many as I'd like. but please recognize that this carbon that has the C double bond O, you don't have any hydrogens because you already have 4 bonds around that carbon, 4 bonds around that carbon. And then we get into what we call carboxylic acids, this is also a C double bond O, but it has an OH group on that carbon, okay? So this is another what we call end group, okay? It's on the end of the molecule, And so again, it could be drawn on the left or the right. It could have as many carbons in there, as long as you have the C double bond O and that OH attached directly to that carbon, that is considered a carboxylic acid, okay? And you already know one, it is acetic acid, and you sometimes see acetic acid written COOH. That is because that is how you abbreviate C double bond OOH in chemistry. All right, so we have 3 more functional groups on this next page. An ester is going to be C double bond O, O, and then you have a set of carbons on the other side of that oxygen. So it's a C double bond O, O. So this is going to be more in the middle of a molecule, not directly always in the exact middle, but it's going to lend itself to the fact that you have to have a carbon on either side. So it's never going to be on an end. It's never going to be on the end. And if you remember from first day, we smelled some esters. These were the smelly things. Some of them are esters, some of them might have been aldehydes as well. So the last grouping here is where we start to introduce nitrogen. And if some of you have had biology, you know some of these molecules already. So amine and amide, okay, they have nitrogen in them. So I have a group of carbons, and then I have a nitrogen and 2 hydrogens. And nitrogen's going to have a lone pair on it, but you're going to see that kind of drop off as we start to draw more of these. So again, it could be as many carbons as you like, but you have 2 hydrogens. And I'm going to keep it pretty simple. I'm going to keep the nitrogen on the end of the molecule, but technically speaking, anytime you see an NH2 in the molecule, that's considered an amine. Okay. And finally, amides. It's kind of the same, but you have a NH2 group attached to a carbon directly to a double bond oxygen. So this is going to be another N group, and it can be on the left or the right. It does not matter. So I'm drawing it on the left just so you could see different versions of this. And please note, with all of a drawing of carbons and hydrogens, you're going to start to see me drop off some of the hydrogens. But if you see a C double bond O, NH2 group, that is considered an amide. That is considered an amide.